Hi, here we've got a Lafayette 60-watt stereo receiver from the 1960s. It's a model LR500T. I think the T is for transistors. It's got 32 of them, mostly germanium, not silicon. It tunes in just the regular AM and FM broadcast bands. I bought this from my upstairs neighbor in 1979 along with some big Criterion console speakers for about $100. Worked fine for 25 years, mostly playing vinyl records. About 15 years ago, it just stopped working. I don't even remember what the problem was, whether it powered up at all, but it was serious enough that I stopped using it. Then somebody gave me another amplifier, so I just never got around to fixing this one. Amazingly enough, I still have the original owner's manual, which has this nice big fold-out schematic of the whole unit. I even have the original sales brochure, which boasts 4 integrated circuits and claims they virtually eliminate electronic interference and bring in weak, distant stations you never received before with amazing clarity, so you can depend on years of outstanding performance. Of course, they don't say how many years. Probably they weren't planning on 50 years of operation. Now, look all through the manual. They don't tell you anything about how it comes apart. I assume that it's going to be these screws on the side. So let's try that. Okay, so that's it. Pretty dusty in here. Here's a probably electrolytic. It's all taped up. Not sure why that would be. I know I didn't do that. But let's try to get this set up for some tests. Okay, so if we look at the layout here, here's the back of the unit. And there's the power transformer. It tells us to expect 32 volts on the secondary winding. And it looks like all the rectifier stuff is underneath. This is the main filter capacitor for the power supply. And this here is the audio output board connected to all these power transistors that are mounted on the back of the unit. So we'd like to find someplace on here that we can measure the main B plus voltage. Well, actually B minus voltage. This is a positive ground unit. So let's just take a look at the schematic. Okay, so if we look on the schematic, of course, here's the power transformer. Here's that big filter capacitor. Here's the positive going to ground. Here's the negative. And here's the negative rail going up to the audio output board. And these terminals are conveniently numbered here. And this is terminal number 26, which should be the B minus rail, also terminal 15 on the other channel. So if we can just find these on that audio output board, we can see if we're getting supply DC voltage there. Okay, we're about ready to power this up, and I don't want to lug the big speakers down here, but I don't want to run it without a load either. So as a dummy load, I've got these 2 big 8 ohm resistors, one on each channel. And so we can hear what's going on. Took a little speaker out of my car, and that's connected through this 27 ohm resistor. So that'll put about 1/10 of the total power onto the speaker. There's a 30-watt amplifier for channel. You don't want all that going into this little speaker. And just to be safe, we'll bring up the power gradually with this variac. Okay, so this is on. variac on. I'm going to bring this up to about 25 volts here. You can already see this bulb faintly glowing. Let's look at the voltage here. 16 volts seems about right. Actually, here's something on the speaker. Let's check the negative rail on DC. 10 volts seems about right. Switching the source here. Ah, there's some sound. Didn't really expect that. Let's bring up the voltage some more. That's about 60 volts. And it sounds like some kind of oscillation coming out of the speaker. Well, let's try the radio.
For Sunday, mostly cloudy weather.
Oh. So it's working. That's not as I remembered it. Well, let's go ahead and bring it up to full voltage here. And now the negative rail. 45 volts, which is what it's supposed to be. Okay, I've had it on for several minutes now, and now a problem has become apparent. And that is, there's kind of a constant low rumble in one of the channels. So I'm going to put this speaker directly on the speaker output to make it a little louder here. And if we go to the other channel, don't hear any of that. It's absolutely clean. So that's one problem. Seems specific to that channel. If I turn the bass control, it's just really noisy. And just in one channel. Other channel, it's not like that. So maybe we just have a dirty control here, but have to figure out how to get access to that pot. It's mounted way down on the bottom there. And maybe we can get at it from the bottom. Oh, there is a plate with some screws on the bottom, so let's see what that does. Great, so there's all the volume and tone controls in. Looks like you can get a nozzle in there. Spray these with some contact cleaner. So let me just get some. Okay, so this is volume, treble, bass, and might as well do all of them here. Okay, let's see if that's any better.
and 2 outs in the...
George Washington is quoted as saying, "It is impossible to rightly govern without God and the Bible." Our nation's history has been profoundly impacted by
That's treble.
leaders who have relied upon God's word to guide them. Andrew Jackson said, "God has ever given to man all the good..."
Well, maybe that was all it was. Dirty bass control. Well, as long as we're here, let's just put some contact cleaner on these switches as well. Turn this off. Some toggle switches up here. Okay, so it seems we've solved one problem. There's really no rumble anymore. If I connect this speaker directly, there's a little bit of hiss, but again, no rumble. And if I turn the bass, no click, nothing. So it seems like the contact cleaner did some good there. But now the distortion on this right channel seems to have come back. Nice and clear in that channel. This channel, the right channel, it's totally distorted. And I won't show it, but it also does that on AM. So it's not a problem in the FM detector. And also, if I switch to mono, it becomes mostly clear. Okay, so problem's got to be after the detector, but somewhere before where this mono switch comes in and joins the two channels. So we're going to take a look at the circuit diagram and see where that is. So if we look at the schematic, here's the source selector over here. This is FM radio, this is AM. That audio signal goes into the first transistor, then the second transistor. So here's the output. It goes through this capacitor and into the resistor network, which is a bunch of attenuators for negative feedback, which for some reason depends on what the source is. But the main audio signal is coming out here. It goes through this monitor switch, then through a couple resistors and over to the left channel volume control. And similarly, the right channel signal is coming through here, comes off here, through this capacitor and through this line, again through the monitor switch, through a couple resistors into the right channel volume control. And then you can see what the stereo mono switch does. When it's in the mono position, it just connects these two signals together, so you hear the same thing coming out of both channels. Now recall that when we put this in the mono position, that you do get a high fidelity signal even for the bad channel, which means the problem has to be upstream of this stereo mono switch. On the other hand, we know the problem is downstream of the source selector because there's a problem both in AM and in FM. So in other words, the problem is somewhere on this preamp board. Now, several approaches we could take. The most methodical would be to get a signal generator, inject a signal here, and try to follow it through to the end, try to find out at what point it's being distorted. Or we can take a shortcut, try to guess what the problem is. And actually, if you listen to the signal, it sort of sounds like a bad bias. In other words, one of these transistors is maybe biased wrong, so it's going into either saturation or into cutoff. And that's clipping off the audio signal, giving us the kind of raspy distortion you hear. Third possibility is to just go through here kind of blindly, measuring voltages and compare them between the two channels. Because we know one channel is working pretty well, and one channel, actually the right channel, is giving us problems. So if we just compare the voltages, maybe we can find out where there's a difference. And if we see a difference, whether that can account for the distortion that we hear in the right channel. Okay, so here's this preamp board where the problem seems to lie. This is actually the left channel. This is the right channel. It's completely symmetrical. So let's turn this on. And I've got the common lead on the chassis, and just going to go through here and measure voltages without worrying too much exactly what voltage we're measuring, and just compare the two sides. So let's start over here, and let's do this side first. So 175, 143. So that's a significant difference, although it could be that these two adjustable resistors are just adjusted differently. So let's just make a note of that and keep going. $330, $316, $174, $141. That's probably related to this same difference that we saw before. So let's keep going. 1661, 1565, very, very slight difference there. 26, 26, 337, 328, 17, 17, so those are all about the same. And these are all reading 0. Let's try a lower scale. I think these are all part of that attenuator system. $27, $260. So that might be a significant difference there, although it's actually less than a volt. But let's go ahead and take a look at the circuit diagram and see what those differences actually were. But first, let's turn this off and see if these two resistors are actually set differently. So this one, about 390. This one reading 600. Okay, so these are set differently. That probably accounts for the difference in voltage there. So now if we look at the schematic here, here are the two variable resistors. They're marked balance, so I guess they balance the volume in the two channels. And they are set differently, and they are right in the emitter circuit of these transistors. So you'd expect if these are adjusted differently, they're going to induce a different voltage there. But that's unlikely to give us distortion. So let's look at this other voltage difference that we got on the other side of the board. So that's at this connection 15. So on the schematic, that's right here. So that's in this attenuator network. So if we follow the lead here, that's going to an electrolytic capacitor. So that shouldn't give us any voltage. And on the other end, it's going out here. This is going to a monitor switch, and I deliberately set this on. So this comes to a dead end here, and if you follow it here, it just goes to the tape out jack, and with the resistor to ground. So there's no way you could get negative voltage on that line either. And here we have what appears to be the feedback loop, and that's going back to a capacitor. So really, there shouldn't be any voltage on this point at all. And that's implying that one of these capacitors must be leaky. Okay, so I've got it back on here. And what's kind of interesting is that this channel, which is the right channel, that's the bad channel. It has just a very slight amount of leakage. But the left channel, which is the channel that seems to be working properly, has a lot more leakage. So I think I'll get the LCR meter and try to check these capacitors. Okay, let's first check this capacitor, because this is right between the output of the preamp and the input of the power amplifier. So I think I've found it here. It's on R431. Here's R431 here. It's a 27K resistor, and we want the end that's not on point 15. Here's point 15. We want this end of that resistor, and that's the positive terminal of the capacitor. And then the negative terminal is on this R423. It says 33K. I found out this is actually an error. This is a 3300 resistor, and that's right here. So this is the actual B minus rail coming in, and we want the opposite end of that resistor. Okay, so positive here. I'm on the 20 microfarad setting, and negative here should be 5 microfarads. We're reading 0.01 microfarads. Let's try a lower scale here. Eight nanofarads. So that's the right channel. Let's do the same thing on the left channel. So this is the leakier capacitor, supposedly. And it's reading 30 nanofarads. Again, should be 5 microfarads. So that sort of makes sense. It has a higher capacity, and that channel is working better. The channel that's not working, or the channel that's giving very bad distortion, has only 8 nanofarads. Of course, we're checking these in circuit. That's not necessarily reliable. I think what I'll do is first flip this over and directly connect the meter to these two capacitors underneath the board, just to make sure I'm getting the right connections here. Okay, we're on the bottom of the chassis now. I think I found those capacitors. Here's ground and rail. Here's that big capacitor right next to them, and here's those two little capacitors. This is the attenuator network, so that's the positive terminal. This is the negative terminal. So let's put it right on these capacitors. So this will be the left channel, and again reading 30 nanofarads. And there's the right channel, again 8 nanofarads. Okay, now again we're testing these in circuit, and that can cause some problems, although I doubt it would make it read 8 nanofarads when it's really 5 microfarads. But just to check, what I'm going to do is, again, put it on the meter and then stick in a 5 microfarad, actually a 4.7 microfarad capacitor, and see how it reads. Okay, so we're on the 20 microfarad range now. Put in a 5. Actually a 4.7, it's reading 4.8. So it doesn't seem to be a problem reading in circuit, and seems like that capacitor really has lost pretty much all its capacitance. So as long as we're down here, let's check this big capacitor, this 50 microfarad. That's kind of in the power supply here. And here's the ground. Switch it to 200 microfarad scale. There's the ground, ground is positive. So there's the positive, there's a negative. And it's reading 0. (200 nanofarads). And that capacitor reading less than a nanofarad. So all three of those capacitors right next to each other there, they seem to have all totally lost their capacitance. Well, let's flip the board over and we'll check all the other electrolytic capacitors in the preamp. Okay, so let's first check this feedback capacitor, which is the other capacitor that could account for the apparent leakage that we saw. So we want the positive terminal on terminal 16, and we want the negative terminal on this 3.3K resistor going to ground. Here's that 3.3K going to ground. So we want negative terminal there and positive terminal on terminal 16, that's here. So 87, it's reading a little high. And let's try the other side. That's reading way low too. Let's next try this 1 microfarad capacitor. Not sure exactly what that does, but here it's connected to that same 3.3K. That's the positive terminal, and then the negative terminal is connected to this 15K, the side that's not connected to the variable resistor. So there's a variable resistor, so we want this side of the 15K is a negative terminal, 3.3K is a positive terminal. It's supposed to be 1 microfarad, so that looks okay. And the other side, one microfarad. So those look okay. Okay, let's try this 5 microfarad on the input. So we want the negative terminal on a 47K, the side that's not connected to a 15K, and then the positive terminal on connection 17. So here's the 47K, here's the 15K. So we want negative terminal here and positive terminal on 17. Supposed to be 5 microfarads, it's reading 8. And the other side. Reading 9. Okay. Okay, so just one more to go here. This bypass capacitor, 30 microfarad. Positive end is on ground. Negative end is on a 560 resistor. And the end that's connected directly to a transistor. That's the negative. And so positive on ground. Here's the 560. We want the end on a transistor that's right there. Okay, so reading 48, and the other channel reading 47. Okay, so I think those are okay. Okay, so obviously you've got some capacitors to replace now, but before we do, let's just patch in a capacitor and see if it fixes this distortion problem. So I've got the clip leads here. They're clipped across this capacitor 416 that we determined had lost all of its capacitance. So let's turn this on. There's the good channel. Bad channel. Just patch in this capacitor. Okay, so that really does seem to be the problem. Okay, so before I start replacing capacitors, I decided to try this again using signal tracing, try to trace the signal through this preamp. First to see if we get the same answer, but second to see just what kind of distortion we get from this bad capacitor. So I've got signal generator here, and it's putting in 700 hertz sine wave. That's going through the auxiliary input of both channels. So here's that signal. This is on half a volt per division, so this is about 1 volt peak to peak. And let's first trace it through the good channel, which is the left channel. So it comes in here on terminal 7. There it is. There's a voltage divider that knocks it down by about a factor of 3. So there's 0.1 volts per division. So we're getting just about 0.2 volts input to the amplifier. And we can follow that. It goes through this capacitor to the base of the first transistor. So let's see if I can get it on there. There it is. So it's basically the same going into the base of the first transistor. So now let's go to the collector of that transistor. That's this 33K resistor right here. And it looks like the signal's disappeared, but it's there. It's just much weaker. So this is now 0.02 volts peak to peak. No, I don't understand this circuit in enough detail to explain that. But I think it has to do with the negative feedback going into the emitter of this transistor. But in any case, let's go to the collector of that transistor. That's this resistor here. It's a 3300 ohm resistor because much higher signal now. So that's the 1 volt scale. So that's about now 2 volts peak to peak. So overall we went from 0.2 volts to 2 volts, so about a 10-fold amplification in what we think is the good channel. So then that goes through this coupling capacitor, and if we look at the other side of the capacitor, it's just slightly reduced. Okay, so that gives us an idea of what we should see if the amplifier is working properly. Okay, so now let's go to the other channel. Here's the input. Okay, back down to 0.1 volts per division. So this is after the initial voltage divider. And it's about 0.2 volts peak to peak, just like the left channel. So then let's go through this coupling capacitor, And here, there's the base of the first transistor. Basically the same signal, about 0.2 volts. And again, if we look at the collector of the first transistor, we get a very odd signal. Well, let's go to the collector of the second transistor, the output of the amplifier. And that output is actually off scale. Let's reduce the scale here. Oh, this is 5 volts per division. So now we've got about 12 volts peak to peak. So in this bad channel, we've got a much greater signal coming out of the amplifier. And the signal is clipped off here at the bottom, it's signaling that this output transistor seems to be going into either saturation or cutoff. So again, let's look at the other side of this final coupling capacitor. And the signals come way down. Okay, that's 0.5 volts per division, so a little bit less than 1 volt peak to peak. So I think we would reach the same conclusion, that it has to be this coupling capacitor, because you get a very high voltage going into it and not much voltage coming out of it. Okay, so why is this signal so much higher in the bad channel? Well, I think what's happening here is this amplifier is actually acting very much like an operational amplifier and an op-amp, in that the intrinsic amplification is extremely high, and then they have a very strong negative feedback, and it's actually the negative feedback that determines the extent of amplification. And we see that the source of the feedback network is after this bad capacitor, and so in fact there's hardly any feedback, and that's why on the right channel the amplification factor is extremely high, trying to drive a very high voltage on the output. And as a result, that's pushing this transistor either into cutoff or saturation. And if we look at the actual curve here, we can see that the clipping is occurring on the bottom of the curve, so that's trying to go to negative. So that would correspond to the transistor being off, meaning that this point here would be maximally negative. So in other words, the transistor is being pushed into cutoff rather than saturation. And let's see if we can actually improve that by just turning down the amplitude of the input here. And sure enough, we can turn it down to the point where we get a pretty nice sine wave. So again, the distortion isn't coming directly from the capacitor, it's coming from the amplifier being driven too strongly and pushing it into cutoff. And of course, when we're actually operating the radio, it doesn't help to turn down the volume, because the volume control is after the signal has already gone through this preamp board. So let's just go ahead and replace these capacitors. I'll replace all the capacitors that tested bad, as well as the corresponding capacitor in the other channel. So to remove these capacitors, I've got one of these soldering irons. So let's just go after these coupling capacitors. There it is, doesn't look too bad. Might be a little bit of corrosion there. So what's kind of nice here is on the board they've numbered all the capacitors, and they even show the polarity of each one. Let's just put this in. Okay, got those three capacitors in. Just clip off the excess. I'll just flip this upside down to solder it. Okay, let's just solder it in. Okay, so I've replaced just the two coupling caps and the filter capacitor. And I think we'll just try it at this point. That's the right channel. It's the one that was broken. Sounds pretty good. There's the left channel. Well, I don't know. Both channels sound pretty good, but they don't sound the same. Seems to be more bass in the right channel, more treble in the left channel. Okay, so just to demonstrate that we've really solved this distortion problem, here I've reconnected the signal generator and oscilloscope, and again we have a sine wave going into the preamp board. It's about 0.2 volts peak to peak, which before was enough to drive this preamp board into distortion on the right channel. But now if we look at the output of the right channel, it's nice and clean, and in fact we can drive it quite a bit higher before we start seeing some distortion. So there we are seeing a little bit of distortion, and that's with an input of almost 2 volts peak to peak, so almost 10 times as much as we were able to put in before we get distortion. And furthermore, if we look at the two channels, there's the right channel, there's the left channel. They're pretty much identical. So we really do seem to have solved this distortion problem. The other thing we can do is try to look at this problem of one channel having too much bass, the other channel having too much treble. And for that, I'm going to switch this to a square wave. And again, we'll bring this down to about 0.2 volts peak to peak. Nice thing about a square wave is it has lots of harmonics, so the shape of the curve depends strongly on the frequency response of the amplifier. Let's look here at what's coming out of the speaker terminal. Now I've adjusted the bass and treble to produce a square wave here, which corresponds to a flat frequency response. But you can see that if I boost the bass here, it dramatically changes the curve. Or if I boost the treble here, that will change the curve in a different way. So if one of the other channels is boosting the bass or treble, we ought to be able to see that as a change in the shape of the curve. So if we look at what's coming out of the preamp, here's the right channel. And here's the left channel. And it's pretty much a perfect square wave. So that means that the imbalance in the bass and treble is not coming in the preamp board. And if we look at the speaker, I've adjusted one channel to give pretty much a square wave. And if the response of the other channel is any different than that, then we should see a difference in the shape of the curve. And we don't. Okay, so we have now pretty much a square wave coming out of both channels at the final output stage going to the speaker. So I think what this is telling us is that the fault that's causing too much bass in one channel, too much treble in the other channel, it's not in the preamp board, it's not in the final amplifier board either. It's got to be before that, probably somewhere in the FM discriminator board. Okay, so here's the schematic of the FM multiplex detector where we think maybe the problem is. And actually right at the output of that FM detector board, there are two electrolytic capacitors. One goes to each channel. So let's just check them. I've got the LCR meter here. We're set on the 2 microfarad scale. And we want to go from terminal 6 to this 10K resistor. So the plus should be on terminal 6. There's 6. Here's the two 10K resistors. Okay, about 1 microfarad is what it's supposed to be. Try the other one, that's terminal 7 and this 10K. Looks like another bad electrolytic capacitor. It's registering 2 nanofarads. Well, let's see, is that in the correct channel? It was the right channel that had more bass and the left channel that had more treble. So if we have a low capacitance capacitor, would expect that to be the channel with more treble. And again, that was the left channel. So if we look on the schematic, this terminal 7, which has the bad capacitor, if we follow that down, that's going to the right channel. So that seems to be wrong. Well, let's just check the connection here. So this is terminal 17 of the preamp board. And if we have that source set to FM, that should connect to terminal 7 of the FM detector. Just turn this to resistance. So we want to go from terminal 7 to terminal 17. And that appears to be an open circuit. Definitely got it on FM. Well, let's try the other terminal, terminal 6. Seems to be connected to terminal 6. So terminal 6 is connected to the right channel. What about terminal 7? Terminal 7 is connected to the left channel. And that's the bad capacitor. And that's presumably why there's reduced bass in the left channel. But that's connected exactly the opposite of what's indicated on the schematic. Clearly on the schematic, terminal 7 goes to terminal 17, terminal 6 goes to terminal 7. I wonder if the FM is actually reversed. The channels are reversed in the radio. That would be something. But in any case, this capacitor could account for the problem with the bass and treble imbalance in the two channels. So let's go ahead and replace these two 1 microfarad capacitors and see if that makes a difference. Okay, so I've replaced these two 1 microfarad capacitors. These are the output capacitors for the FM multiplex board. Also these two capacitors, one of which tested bad. These are the feedback capacitors for the preamp. And now both channels sound pretty much the same. That's the right channel. That's the left channel. Getting pretty good bass in both channels. Okay, so it's working pretty well now. Got the stereo indicator light here, and you can see at least on some channels we are getting stereo. So I think I'm pretty satisfied with it now, but probably what I should do here is at least go through and check every one of these electrolytic capacitors. I think I've found about 6 that have failed. So just go through and see if there's any more I want to change. Okay, I've checked every capacitor in the receiver now. I found only one more that's substantially below spec. That's this one right here. This is at the input of the power amplifier. So if we look at the left channel, it's supposed to be 10 microfarads. It's reading 14. And the right channel, again, supposed to be 10. It's reading 0.3. So we just replace both of those capacitors. Okay, I got these two final capacitors installed. Just going to do some quick tests here. Turn it on.
Has contributed to the economy of Richmond with jobs and community.
It's the left channel. It's the right channel. So it sounds pretty good. I can't tell any difference between the two channels. And we're picking up lots of stations.
United Health.
Getting to be too much.
It's really difficult to even find a dead spot.
Finding purpose. Real people.
Well, at this point, I'm pretty satisfied with the sound. I know a lot of people would say you got to replace all those capacitors. There's about 50 of them. Maybe I'll do that at some point, but there is a risk if you do that many, you're going to break something or overheat something or short something out. Anyway, for now, I'm just going to put this back together and enjoy it. Okay, we're back upstairs. There's my big Criterion speakers. They don't make them like that anymore. These things weigh about 40 pounds each. And they still sound great with this receiver. Because we can't play the radio, we'll get a copyright hit, but I've got some non-copyright fiddle music from Mr. Zachariah Hickman. So, just to show that it works here. There's the left channel. Right channel. Both channels. Bring up the bass. Treble. watching.